This podcast is focused on the fraudulent argument that reading is the same as training on intellectual property. I'm going to debunk this from a mathematical perspective and explain why the math just doesn't work for that argument. First up here, let's talk about this concept of pattern matching versus content comprehension. Reading is not training on intellectual property. These are opposite types of techniques. One is math and the other one is a human behavior. Let's take a look first at the math here with the core mathematical distinctions in terms of the dimensionality, right? Human reading is processing sequential information. You're not going through and going back and forth and looking at certain words and finding statistical correlations. You're reading it in a sequential way. And so in the case of machine learning, though, you're building statistical correlations across high dimensional vector space. So let's take a break for a second and get into the math behind, let's say, k-means clustering, which has some of the similarities with large language models. The reason I bring up k-means clustering is it's very simple. You can write the code yourself. What happens is in a multidimensional space, let's say it's XYZ, we have age, we have weight, and we have the height. You could plot different people in high school and you could find the wrestlers, you could find the women's soccer players, you could find male basketball players, you could find male football players, etc. That's a multidimensional space where the distance then creates the label. So in the case of the machine learning, there is no value unless you have the actual data, and you need a large quantity of data to make a decision. So here's where we get into the data quantity thresholds. With pattern matching systems that require massive data sets like generative AI, in order to establish statistical significance, the N has to be way over 10,000. In terms of human comprehension, you can operate on a limited example. Maybe N is under 100. So there's very different behaviors from a mathematical standpoint than human comprehension. And in fact, the whole concept of the pattern matching system is a very simple concept, right? In multidimensional space, you're finding the distance. Human, again, you're reading things from a sequential level. And if we get into the information density processing, so with k-means clustering and vector similarity models, so again, like a vector database, you're extracting the pattern through the probability distributions and distance metrics. And this is effectiveness that scales logarithmically with the data size. So now let's get into the labeling problem in limited data context. So in terms of mathematical insufficiency, the pattern recognition systems are going to produce statistically insignificant results if they're trained on small sample sizes. So k-means clustering, if it doesn't have enough data points, it will create an unstable centroid, or vector embeddings will develop like high variance versions in low data environments. And this is going to give you unreliable similarity metrics. And then also in terms of annotation density requirements, in order to have a meaningful label, it's going to require contextual reinforcement across thousands and thousands of similar examples. And then finally, in terms of error propagation, limited training data is going to exponentially increase the propagation of statistical anomalies. So we see here, these are very different ways of looking at the world. And then we have the smoking gun, in my opinion, which is criminal intent. If companies are deliberately using dataset privacy, that should show you the intent is criminal behavior. So if we look at the mathematical distinction between like incidental exposure versus systemic extraction, with reading, you're basically constrained, right? There's lossy information absorption with natural forgetting curves, but with pirated data, this is deliberate, persistent data capture designed for complete pattern extraction. Also, you have to make the decision to target pirated data sets. There's also the scale-based legal threshold. So the criminal intent would be demonstrated through circumvention of the technical protections, right, to mass harvest content. So people are not going to the library or going to a book vendor. They're going to pirated data sets intentionally. Also, systemic scraping operations will exceed the fair use, right? So there is no consent in terms of the systemic scraping. And then there's also the deliberate removal of copyright attribution or licensee metadata. So let's say in the case of GitHub, many repos are actually labeled Creative Commons non-commercial. If you went to that repo, you deliberately scrape the data and then remove that license, you're intentionally violating the copyright of that information. Similarly, if there's a book and it has a specific clause that says it's not allowed to be used for commercial use, etc., you're deliberately targeting that for criminal intent. Now, how could we get into the details and figure this out? Well, there's forensic fingerprinting, right? So the pirated training data sets do leave detectable statistical signatures. You can look at content regurgitation patterns as well. Clustering analysis could reveal unauthorized distribution centroids. And then also, if you look at the embedded proximity patterns, they could show an overrepresentation of the protected material. So there are ways to find out specifically if pirated training data sets were actually used in training models. And then if we look at the proprietary information analogy and get into the math here, there's this concept of information exclusivity. So let's say you wanted to go into Coca-Cola headquarters and you said, look, I want the formula. Well, why would Coke give you the formula? This is a constrained mathematical solution space with intentional limited distribution, right? They don't want you to know what's inside of Coca-Cola because that's a trade secret. Likewise, you can't just walk into Tesla or NVIDIA and say, hey, I want to know your sales figures, because that's a competitive intelligence limitation, and they have isolated data points that they're protecting. In terms of the complete data set requirement, these pattern matching systems cannot reverse engineer the proprietary systems unless they have access to the complete feature space. So that's really the secret here, is that the data itself is part of the value, and the math is pretty clear, right? In the case of k-means clustering, if you don't have the X, the Y, and the Z, in the case of the age, the sex, the height, how could you possibly figure out the other patterns? So really, if we get into the essence of the argument here, is that the statistical approximations versus the structural understanding. In the case of reading, humans develop a concept, a framework that allows you to transfer the learning across domains. But with training, the ML systems are using statistical correlation. So very different patterns. In terms of content window constraints, modern AI systems operate within finite context windows, like let's say 8K to 128K tokens, or some of them are going bigger, like 1 million tokens. But human comprehension integrates information across years of accumulated knowledge. And then we also have the cross-domain transfer efficiency. Humans could require a lot more examples to generalize concepts across domains, but pattern matching systems require even more to do similar performance. So there's differences in the way that a human would generalize concepts versus a pattern matching system, in that the pattern matching system requires much more data. And then we also have the legal and ethical problem. So if we look at quantifiable extraction metrics, training operations can be measured, right? So what's the total extracted token count, billions and trillions? What is a complete versus partial work, like an entire book versus an excerpt? And then we have retention duration. Is it permanent versus temporary? And so this gets into the fair use boundary violations. Reading is established legal doctrine, right? Like we've already created laws for this. Whether you agree with them or not, it is the law. Systemic extraction for model training is a very different usage pattern. And so it's really about exploiting a new type of way of working with the data that doesn't have an established legal document. And in terms of the intent evidence trail, you can look at things like, when people are targeting these pirated data sets, where is the development documentation? What is the data pipeline architecture? What is the extraction methodology? So you could definitely get into the weeds and figure out that companies are deliberately targeting these pirated data sets by looking at the software infrastructure of their organization. So really, in a nutshell, to wrap up here, there is a mathematical burden of proof. Like the current pattern matching systems demonstrate that they have access to comprehensive data sets, and those comprehensive data sets are required to produce the value. And then from an information theory perspective, you can see that you cannot circumvent these through algorithmic optimization. You need to have the full data set. And then there's a very different quantifiable difference in consumption. So in the case of reading for comprehension versus training for pattern extraction, these are very different mathematical operations on the same data. Like you don't read a book by plotting it in multidimensional space and then finding a cluster and then reading the cluster, right? That's a very different pattern than what's happening with these machine learning systems. So you can think of things from a mathematical framing perspective to provide concrete evidence that the training patterns that are happening on intellectual property are very different fundamentally from human reading. And there's distinct technical requirements, there's operational limitations and outcome. And so this is a way to clearly prove that there is a fraudulent process of collecting data that's very different. And this is an unauthorized exploitation of intellectual property in the commons. So I think this is a very interesting way to think about it, is the math just doesn't work to say that you can read a book and it's the same as training on millions of books or billions of intellectual property images. And if you think about it from a mathematical perspective, it really starts to debunk this idea that pattern matching is the same as content comprehension.